All right, welcome to part 2 of section 3.10 here, where we're looking at trig equations and trig inequalities. So we just rocked some trig equations. Now let's focus on the inequalities. Let's get this going here. So let's do this bad boy here. Don't freak out if it's an inequality. We're going to solve this the same way. We're going to add 1 to both sides. We're getting net x by itself, so we're just solving an equation. In this case, it's an inequality, not an equation. We're going to divide by 4 here. So clean this up. So now we're looking for, hey, when does the cosine of x less than negative 1/2? So if you want, let's just use our unit circle here. So yes, I'm going to take let's do arc cosine here. Same thing. So same as inverse, but I want to use both notations. So the arc cosine of cosine, we're taking the inverse. And then, oh, it's just so much writing. When does this cosine equal negative 1/2? So we're over here saying, hey, when am I going to get that cosine value of 1/2? And when is it going to be negative? So it looks to me like we're going to say, okay, it's going to be from this angle here. Where's cosine negative? Pump fake. It's actually over here. Cosine's negative here, and cosine is negative here. So those are my two answers right there. Cosine is going to be negative, so these cancel out. So the angle I'm looking for is going to be the inverse cosine of negative 1/2. So that is going to be what? So this is pi over 3 in the first quadrant. So I'm going to be pi over 3 less than pi. So I'm looking at 2 pi over 3. Awesome. That's this distance from here to here. I'm sorry, this is the 2 pi over 3. Then what is this angle over here? I'm pi over 3 past pi, so I'm at 4 pi over 3. So there are my two answers. But the question is, hey, when am I less than? So I have to think about when am I going to be less than, let's go back to this equation here. So when it's all the way solved to this, so I'm going to have multiple answers. It's going to be a range. So really I'm thinking about, am I going to be less than between these two on the unit circle, between here and here, or on the bigger side over here? So you can plug up points. You can think of the number line. Okay, I'm thinking about, well, here's 0. Here's 2 pi over 3. Here's 4 pi over 3. Now this can be tricky when you're doing exact values because I got to make sure I know the exact values of what's going on here. So pick a point. I like to pick one that's in the arc right here. Here's an easy point, pi. So pick the point pi. What happens when I put pi in there? So I go and let's plug pi in there. I'm going to say, hey, what is the cosine of pi? Is it really less than negative 1/2? I'm checking the point. So the cosine of that is negative 1. Is negative 1 less than negative 1/2? It is, yes. So I know this is the correct shaded region here. So we can do a quick number line. So my answer is going to look like this. I want all the values of x that are squished between 2 pi and 4 pi. So if you pick something on the other side of the circle, not going to work. Another way to think about this is just to graph it. Usually if you're finding exact values, they're pretty chill to graph. And it can be super rough sketch here. So if I graph just this, y equals 4 cosine x minus 1. So give yourself like a little midline down here at negative 1. And then you're going to say, I'm going to go, a cosine graph starts above 1, 2, 3, 4. So maybe I'm up here at 4 above. It's just a normal cosine, so it ends here. I'm going to be down here at negative 5 in the middle. So this can be a really rough sketch. The idea is if I make a little rough sketch, oh my gosh, I think I missed my pi. That's why it looks a little weird. Let's center that pi. I was like, hey, you're not looking very symmetric here. That was a rough looking cosine. So if I make this rough sketch here, whoosh, there's the cosine. And then what's the cutoff? The cutoff here is when is that negative 3. So down here at negative 3, this will be negative 3. There's my midline. So now I'm saying, hey, when am I lower than negative 3? Well, I'm lower than it. Let's get the highlight. I love the highlighter. This is where I'm lower than negative 3, all this region here. And where do you think those points are that it intersects? Well, we found that. That's your 2 pi over 3. And mine is not super to scale here. That's your 2 pi over 3 and your 4 pi over 3. So I think on the answer key, I showed the graphing version of it. If you want to graph it, if you'd rather just plug in points from the unit circle, I'm cool either way. Make a little number line as long as you get the right answer. So now we're given a whole region, and it's in this restricted domain. We're not talking. This will always be a restricted domain. We're just looking for that little spot right there. Holy cow, we're getting there. Let's take a look at the finale, the big dog here. We're back to exact. I like the exact ones. Now what we're going to do is we're going to mess with the period. You see how the period got messed with? We're going to do like a little horizontal shrink here. Don't freak out. Just solve it. It always just solves it for x, just like normal. You're going to get that equation by itself. So I'm looking for theta. If you want to call it x, you can call it x. And I'm actually good to go right here. So the cosine of 2 theta equals 0. So what do I do to get rid of cosine? I'm going to inverse cosine it. So I'm going to do this. And then whatever I do to one side, I got to do the other side. So now the only difference here is these cancel still. And I've got 2 theta equals the inverse cosine of 0. And so what is the inverse cosine of 0? Oh my goodness. So now what is the inverse cosine of 0? I can go over here to my unit circle. And I'm going to say, hey, where do I get cosine value of 0? It's going to happen here up at pi over 2 and down here. So I'm going to get two answers here. I'm going to get pi over 2 and oh my gosh, pi over 2 and 3 pi over 2. I get two spots. So I usually like to write this one out when I have something over here because I'm not quite done. I got to solve for theta. So I like to write them out as, yes, when does this angle 2 theta equal pi over 2? And when does it equal, let's write it again, when does 2 theta equal 3 pi over 2? And now imagine if we were doing all exact values, which we are. So yes, it's going to happen here. It's going to happen here. So normally this one is just a plus pi. So I would have been okay. Let's just write, if I had these two angles, as plus 2 pi n plus the 2 pi n. So if I keep them as separated angles for all possible things. And then now I want to solve it. So now when I go to solve it, what do I got to do? I got to divide this by 2. So that's going to get me back to my angle there. And now, what is pi over 2 divided by 2? Well, if you take pi over 2 divided by 2, you get pi over 4. And then what happens to this bad boy right here? The 2's cancel. So we're going to cancel that and say pi n. Awesome. Same thing over here. We're going to solve this one. Divide by 2, divide by 2. So we're going to end up with 3 pi over 4. And then the 2 pi over n goes to pi n. Awesome. So we cut those in half right there. So what's nice about that is, think about what's happening here. We've got this cosine, that's our period. It's happening twice as fast. We're getting more answers here. So if we cut them in half, this will generate all possible answers. We should say where n is any integer for that. Okay, I know that was exact values, but I just want to show you on the Desmos here. So I solved it for 0. So I solved that. And let's see those answers. So remember, it happens at pi over 4, plus it happens pi later. So what's add a pi to that? There's your 5 pi over n. Plus it happens pi later again. So you're always adding pi to those. And then the other answer here was at 3 pi over 4. Oh my gosh, there's so many dots here. There's so many things going on here. But you can see all those in there to generate all the possible answers forever and ever and ever. So I know it's a lot at first. Get some practice with it. Practice solving them, finding them. It's a good section. Good luck on the mesh check. Peace out.